what is this title? Is it possible to minimize the negative effects of anti-nutrients in plant-based diets for European sea bass? I will present the part 1, and my colleague Morgan Henry will present the part 2. So to answer this question, we have to run a trial, which is in Fish and Feeds Work Package 4, to see the use of plant protein ingredients which are subjected to thermal treatment, vs. enzyme addition in diets for European sea bass. And what I will present you is their effects on growth, feed utilization, and digestibility. The health issues will be presented by my colleague Morgan Henry. So just a little bit, in order to evaluate the use of high protein plant-based ingredients as alternatives to fish meal and fish oil, we have to consider that plant proteins, they have a high content of anti-nutritional factors like protease inhibitors, lectins, tannins, phytic acid, and NSPs, which lead to impaired growth, poor nutrient utilization, and several health issues. It is documented that in other species, when we supplement the diets with additives like enzymes, or if we treat thermally the raw materials, we may improve growth performance and feed utilization by improving nutrient digestibility to the end. So is what we have done in this trial. We try high protein alternative raw materials which were subjected to thermal treatment, or there was used as there were with the addition of enzymes. We choose 3 different commercial products, guar meal, rapeseed meal, and sunflower meal. The 3 of them had a high protein content. Guar meal has almost 53%, sunflower 44%, and rapeseed meal 32%. All of them are high, not all, the 2 last ones are high in NSPs and of course full of anti-nutrients. Here we formulate 2 diets, the control diet with 20% fish meal, and the negative control, which contain 10% of each of the plant raw materials mentioned. In the control negative diet, we just mixed all the ingredients together without doing anything. In the treated diet, we took the raw materials one by one and we boiled them with the addition of 50% water, stirring 15 minutes, keeping the temperature at 60 degrees, drying at 40 degrees, grind the material, and proceed with the mixing and the extrusion. In the other 2 diets, we add SSF. It's a product, it's a commercial product, a natural solid phase fermentation complex from Aspergillus niger that contains residual enzyme activity. This product was added at the SSF diet at 0.05% prior extrusion. While in the FIXIL diet, we add phytase and xylanase at 0.01% phytase and 0.03% xylanase after the extrusion together with by coating. So we formulate, we product these 5 diets extruded containing almost 48% protein and almost 17% fat. We ran a growth trial where we use sea bass of 19.5 grams in an open flow through system, 90 days at 23 degrees, feeding 3 times per day. We measure growth performance, feed utilization, protein efficiency, of course, whole body composition, digestive enzymes, antioxidant biomarkers, immune response, and gut histology. I don't have results on gut histology, I'm afraid. I put this, but to the end, I couldn't find them. Anyway, let's see the results now. Specific growth rate, what we saw. Significant better growth in the supplemented and the treated diet compared to the negative control. The exogenous enzymes addition, the phytase and xylanase, significantly led to higher growth rates. Concerning the FCR, significantly better FCR with the enzyme supplementation or the thermal treatment compared to the negative control. Per protein efficiency ratio and an apparent net protein utilization, significantly better with the enzyme supplementation and the thermal compared to the control, to the negative control. Body composition, significantly higher fat was found in the positive control, lower in the negative control, significantly lower. And in the rest of the diets, the enzymes included and the treated, we saw an increase of fat. So it was, let's say, a bit better. Digestibility trial. After the growth trial, we took the fish and we brought them in a system, specific system for collecting feces. We continue to feed for 5 days acclimatization because there was a changed environment. And then for 10 days, we were collecting the feces at 23, 24 degrees. We measure the apparent digestibility of protein, fat, starch, carbohydrates, and phosphorus by yttrium oxide. Okay, this is a known method. And coming to the digestibility, fat was significant, protein digestibility was high in all groups, close to 95%. Fat digestibility was higher in the control diet, but when we add the phytase xylanase in the last diet, there was an increase compared to the other two diets, the SSF and the treated diet. Carbohydrates showed significant lower NADC in the control minus diet, as you can see here. But while the supplementation of the enzymes as well as the heat treatment of the raw materials resulted in carbohydrate improvement. And lastly, phosphorus ADC was the highest in the SSF diet, solid state fermentation product, and the treated diet, CC. So, concluding, growth performance indicators, feed utilization and protein efficiency were significantly improved by either the inclusion of the exogenous enzymes or the thermal treatment in the raw materials used. Body composition was affected only in the fat and moisture, because these are inverse. Significantly higher fat content in the control, in the positive control, while the negative was lower, but the addition of the enzymes and the treated was, let's say, in the middle between the control, the positive and the negative. Fat digestibility increased significantly by the addition of the two enzymes, phytase and xylanase, compared to the negative control, while there was no effect in the SSF and the treated diets. Carbohydrate was increased significantly by the supplementation of the enzymes, as well as by the heat treatment at comparable levels to the positive control in respect to the negative. And finally, phosphorus digestibility was improved in the solid state fermentation diet and the treated diets. That's it. Thank you very much.